Hello and welcome to the Unnamed Reverse Engineering Podcast. I'm your host, Alvaro, and hosting with me today is Jen.
Hi.
Our guest today is Nika, also known as Ice Queen on the internet. Welcome to the show.
Hi, thanks for having me. Happy to be here.
Yeah, we're super excited to chat with you. But before we get to that, can you tell us a little bit about yourself?
Yeah, so I am a security consultant at Leviathan Security Group. So I mainly work on hardware and embedded security testing. And then outside of work, I have a ton of reverse engineering projects that I'm working on. But the main one is 16-bit MS-DOS malware, which I've been working on for the last year or so.
Awesome. Yeah, I will say that this is how I guess I heard about you. Well, I met you at a meetup in San Francisco, and then you were presenting about 16-bit MS-DOS malware, which I thought was the coolest, and really loved the talk. So had to send it to Jen, and then we had to have you on here.
Well, which meetup did you meet her at?
The Hardware Happy Hour that Chris Gamble started many years ago in Chicago.
Okay.
Yeah. And then it was a B-sides, and we're going to have links to all these things in the show notes. But I always like to start with, how did you get into reverse engineering? How'd you end up here?
So I guess I've been like reverse engineering to a degree since I was little. I used to just like pick apart different things around the house, or just trying to understand systems or ways that a lot of art was created. So I think that was some of my earlier reverse engineering, just trying to reverse engineer the artistic process of different artists. And then I got into more tech-based reverse engineering the last, I guess, since university. So like 8 years or so. And started with software, and then got into embedded firmware, hardware reversing. And that's kind of where I found my niche, with like lower level stuff and really close to the machine. So, but I love it all.
So, I mean, since you've been focusing so much on kind of 16-bit stuff, maybe we're not ready to go there. I was going to ask like whether like, well, because like modern embedded is, I mean, pretty much everything's at least 32-bit. There's so few people that are still doing 16.
MSP 430.
Are you? Is that the hill you're going to die on? It's a very short hill.
That's just how I learned assembly in college. It's just
mine was the HC 611, whatever the heck it was, and somebody was like playing around with that the other day on Mastodon, and I was very amused. But that's neither here nor there. So going back to the question. So do you feel like there's kind of a different mindset between people who mostly operate in 32 and above versus 16-bit and below?
Yeah. So yeah, I don't want to presume how other people work or what people are thinking about when they're approaching problems. But from my perspective and my experience working in 16-bit and like this space for a decent amount of time now, a lot of the other people who I've connected with who have experience with reversing 16-bit, especially 16-bit DOS malware, are people who were either writing malware at that time or who were, very active and getting their starts in either reversing or just security or hacking or computers, what have you, and being on BBSs and IRC at that point in time. So that's the main group of people who I think have the most experience and who I talk to a lot in relation to this project. But I think there's so much applicability with reversing 16-bit DOS malware to modern systems and like a variety of things. So it's a space that's very interesting and exciting to get into, and then being able to take that learning and applying it to different problems, even if it's not, same like 16-bit architecture.
I have a follow-up, and it's maybe because I'm leading towards a particular point. Do you think that possibly those learnings being applicable is possibly because of its because of early PCs' foundational impact on what people have subsequently done throughout the rest of the industry. And so, like, people don't tend to deviate that much from the techniques or the architecture style or design style. And that's just kind of getting carried over into other processor families and yeah, basically other processor families.
Yeah, absolutely. And I mean, I think one of the clearest sort of paths from the original 16-bit DOS samples that I'm looking at to modern malware or modern exploit development connections that I've seen is just the long-standing legacy of the legacy BIOS and how I mean, even if you're looking at a legacy BIOS today, you can really apply any of these 16-bit assembly techniques and tricks because they're calling, for the most part, like similar interrupts. They're using pretty much the same code patterns in terms of checking things during the boot process, things like that. So the legacy BIOS, I think, is the clearest sort of stepping stone that links these two groups.
I have a feeling we'll revisit this later on because there's so much stuff. So thank you for answering that.
So I guess my main question is, why did you choose the MS-DOS era malware? What drew you to it initially?
Yeah. So I think it kind of chose me, honestly. But the first, I don't know, the catalyst for me looking at this malware in the first place was I was listening to a Darknet Diaries podcast episode with, I probably won't pronounce his name correctly, so I apologize in advance, but Mikko Hupponen, who created the Malware Museum on the Internet Archive. And he was explaining it on this episode. And I thought, okay, this is interesting. I'm going to check it out. And so I looked at these samples and I was just blown away. And I decided, like, this is exactly what I've been looking for in terms of a project and pieces of code, essentially, for a really long time. It's exactly combining so many different areas that I want to look at and want to dig into. So yeah, I just got really obsessed with them and I love them. And I think they're just endlessly fascinating. So
I love that it was Mikko. He's a legend. If people aren't aware, Mikko, I guess he started F-Secure way back when in Finland and has been doing this for forever. He's such a awesome resource. Like, if you like following folks online about security stuff, Mikko's fantastic one. And yeah, now he's got the Malware Museum.
Mm-hmm. We'll have to put that in the show notes.
Oh, absolutely.
Yep. All
right. So you heard Mikko, went and looked at that. How'd you actually get started? I assume you can download some of these malware samples online. How do you choose, like, oh, let me try a look at this one? And then also, how do you look at it? Now you have an old executable, or maybe not necessarily executable, but how do you start looking at it? How do you play with it?
Yeah, where do you start?
Yeah, that's a good question. So when I initially started, I did use the samples from the Malware Museum on the Internet Archive. The thing about those samples is that they're all defanged malware binaries. So that means that they're binaries that have had the malicious functionality that was originally present removed. So in their current state, of their defanged state, they just essentially will display a graphical payload or print characters to the screen, whatever the creative quote unquote payload was originally. So I started with that in terms of looking at the graphics components, because that was one of the main draws for me at the beginning, just from an art background. Why are these VX writers inserting what looks like really pretty functionality into something that's supposed to be malicious? What's the point? So I approached it from that perspective, got a little bit more up to speed in terms of basics of writing 16-bit assembly and the basics of writing programs on DOS. And then from there, it was a long process of combing through archives, getting resources, ordering a lot of books on Amazon, paging through reference materials, figuring out all the interrupts, and then building tools to help with analyzing them. But a lot of the samples that are available and that are on repositories that I've used, so like the VX Underground repository that has a really vast collection of source files for these viruses, but they're just the source assembly in the majority of cases. There's like one or two that are basic, and then like I think I've seen a couple in Pascal. But yeah.
That's a blast from the past.
Yeah. So they're pretty much all assembly, and then looking at those, I mean, I've just been reading through them and looking at them from that perspective. But then looking at the compiled binaries requires getting the assemblers essentially that were used originally, which has also been a process of finding, oh, where can I get a copy of TASM? Where can I get a copy of FASM? Where can I get MASM 32 with the 16-bit linker? That's a bit of a process to set up. And then assembling them, looking at the binaries. And I like R2 for doing that, but also IDA.
Gosh, I have like 3 questions now.
Yeah.
That have all do they still make MASM? Because I remember it costing a lot when I was in college. Like,
yeah. Okay. So the thing about MASM or MASM 32, it's bizarre. It's just like, it's such a trip. It's so many weird little gray boxes. In the like top corner, there's a button that's a car, and that's the button to run the executable, which I just think is like, it's insane.
I don't even remember vaguely there being anything like that.
It's such a strange like
it's
UI.
It's like remember, is it Logo with the turtle? It's like they say like, look, people, you know, they want like turtle like interface, but we can't do the turtle, so we're going with a car, but we're still assembly.
Exactly. Yeah.
Okay, cool.
The design choices confound me, and I love them. So what can you do?
Going back even further, I'm trying to pop my stack is already like flooded everywhere. So you worked with the defanged versions of the viruses.
Mm-hmm.
Have you ever gone and tried to work with the fanged versions?
Yes. Yeah. So the fanged versions of the viruses are all on sites like just different virus exchange websites. So like the VX Underground repository on GitHub, where they're all the original, or sometimes they're the original source file, and then sometimes they're a disassembled version of the source. So it's someone else's disassembly with notes, and then using those, I download them and I assemble them, and then I run them and go through that process.
What does your sandbox look like for that? It's just like a separate old machine, or?
Okay, so I have a whole bunch of different VMs set up for it, just because MASM 32 plays more nicely in a Windows VM. But I also do use a Linux VM for a lot of it, just because if I'm writing things and working with NASM, which is my favorite assembler, but no one used it back then. So changing like the macros and everything is such a fun time. So I have a Linux VM, and then for dynamic analysis, it's mostly like using Cutter or R2, and I have like an R2 plugin that I wrote to help with like automatic annotations of interrupts. And then I do either QEMU with a FreeDOS installation and then like loading them onto that, or I'll run it in Box, because Box has like a nice built-in debugger that has good integration with Cutter and IDA.
Yeah. So you're saying that the NASM wasn't heavily used I'm assuming back in the day, sometime in the 90s.
Yeah.
And I would assume that the reason why it was not just that Linux wasn't popular, but it just installing Linux back then, I know, was like 90 plus floppy disks. I can't imagine what's 2 more. They're like, I gotta get another package because I went over the 90. They were sold in a box of 10. So is it still a popular package to be used, or are you also like kind of going to BitSavers type thing to like get like an older version of NASM?
Oh no, I'm writing it and running it with the current version of NASM. So NASM, like, it handles 16-bit binaries just fine. And there's like lots of tutorials and stuff online for there's actually someone who I think is very cool wrote a book called Programming Boot Sector Games. And all of their examples are using NASM as the assembler.
I would say Jen mentioned BitSavers. You meant that's bitsavers.org, right? Is that what you're talking about?
Yeah.
Do you know about that one?
Oh, what is that?
I think you will like it.
You will appreciate this in your line of work.
Bitsavers.org is an archive of all things software, manuals, actual software. It's just, it's a gem. We'll have links in the
sweet
in the show notes, but it's a fantastic resource for old software.
Yeah. I had one more question.
All right, keep popping that stack.
Then I'm done. Then I'm completely out of it. Unless
I have a couple myself.
I know. And this is not only because I don't know, but this is also because I suspect our audience may know. What does VX mean?
Oh, okay. So yes, that's a good question. VX stands for virus exchange. So, but it's also used interchangeably, sort of as a term for viruses or like virus writing. Okay. So, when I refer to a VX author, it's a virus writer, or I guess colloquial now would be like malware author or something.
Okay, and not VX Works. Because nobody wants to talk about that.
No. I don't even know what that is. Like,
it's an RTOS.
It's an RTOS. No, it's an RTOS that it's a very expensive RTOS that nobody uses anymore.
I mean, NASA used to use it, right?
Medical devices use it. Cell phone exchange, not cell phone exchanges, like back end network equipment uses it.
Fancy RTOS is
fancy.
VX Works.
Nobody needs it. If you get any radiation therapy, they're using it.
Probably.
Yeah. Anyway, that was all my questions. Hey, did you have questions, Alvaro? Now that I
think we covered. I was gonna ask about the VX for everyone. So we're synced on that one. What else did I have here? Box. You mentioned Box. What is that?
Yeah, so Box is an emulator. It's an IA32 emulator, and it has a nice built-in debugger. And it's pretty minimal. It's kind of like a bare bones emulator, but it can handle things for... Specifically, I've been using it a lot for testing and debugging bootkits, just because you can like write to like a virtual disk image really easily and then test it in Box and then and like step through it and which is nice.
That but not VirtualBox.
I'm in VMware, but I mean VirtualBox is fine if you use VirtualBox.
Just clarify.
But is this emulator, is it BOX or like BOGS?
It's a Box, so it's because they all have different spellings. This one is BOCHS.
Oh, okay, yeah. See,
I wrote it wrong.
No, because we do show notes for all this stuff, so gotta get these spellings
Sounds
right.
very
Otherwise,
Eastern European.
Yeah, I think that's why I'm drawn to it. It's just like,
yes.
You know.
There's not enough Z's and J's in here, though.
That's true.
You did mention bootkits. Could you tell us what defines a bootkit?
Yeah. So a bootkit is commonly contrasted with a rootkit. So a rootkit is a type of malware that's essentially trying to get root on a machine and do malicious things within the operating system, I guess is a layman's description of a rootkit. But a bootkit, by contrast, targets lower level abstraction layers, and specifically it targets the early boot process. So it tries to install itself during like initial boot up and take advantage of different data structures in different areas within the code that it can hook into and install itself in order to essentially achieve a greater level of persistence.
Sweet. And okay, back now we're back to the document we have with questions, because the last 15 minutes I think we were just excited
It's
about side
fine.
questions.
It's fine.
No, this is why we do this. But I do want to ask you, what are some things you've learned that you haven't expected, I guess, from looking at MS, like older malware?
Yeah. I mean, a lot of things. I think one of the one of the things that really stood out to me, and it was something that happened, or that was the result of conversations I had pretty early on in the project process. So when I was talking to a lot of different people, and I've mentioned this in my talks as well, but a lot of people had a response of, "Oh, the '80s. That's when malware was just about drawing pretty pictures and didn't do anything that intense." And so that was sort of a misconception that I wanted to see. Like, let's test this. Let's see how accurate this is. And it's not. So that was a fun realization, and some validation for me, and just continuing with the project and digging into it more and understanding, okay, why are these VX writers incorporating graphical payloads into programs that are performing really malicious functionality and, encrypting drives, or overwriting files, or making the system completely unusable. And I think from that perspective, one of the interesting things that I learned came from reading the source files, or just like reading through zine archives of a lot of these different virus writers, and seeing a lot of them talk about how they're using viruses and virus writing as a creative outlet and form of expression. Sometimes they were using it as a way to like interrogate current events and talk about it in an online space that was maybe more receptive or more open to that. And then also really learning everything about the operating system and being able to manipulate it and shape it like an actual like artistic medium.
So do you think it, I mean, I'm going to say this word and then I'm going to cringe a little bit for myself. So do you feel like it was their way of doing hacktivism, to get attention towards whatever concept that they were trying to push forth, through this art, through possibly a political statement?
Yeah, definitely. I mean, not all of them, because some of them were just writing silly viruses to, ruin someone's day, or do something malicious and infect as many machines as possible.
Yeah.
But yeah, there was definitely, I think, a good subset of virus writers who were using it in terms of being able to talk about certain political events of the time. I mean, like there's a virus writer who I love. His name is Spanska, who he's like a French virus writer.
Mm-hmm.
And I like, there's other things about his work that I want to talk about, but
Yeah.
in some of his viruses, he has really specific call outs at the beginning. Like there's one it's called No Pasaran, and it's just talking about like the Spanish Civil War. And then there's just other virus writers who are talking about things that are very pertinent of the time. And it's just in these little notes at the beginning of the files, and I think it's fascinating.
That's really cool. So what else did you like about Spenska? Tell us. You mentioned.
Since
Let's
you
get
said
into
you would
it.
eventually talk about him.
Yeah. So Spanska was one of the first virus writers whose work I found who felt like finding a kindred spirit amongst these, like, oh god, that's so cringe for me to say that, but it did, amongst like this virus scene, because there's several of his viruses where he has a call out very specifically of coding a virus can be creative, or there's quotes of him being interviewed where he's talking about, as a virus writer, it's really boring for me to just overwrite a file or delete a disk, or encrypt a disk, or what have you. I would rather spend weeks coding a beautiful VGA effect. And I remember when I read that, I was like, wow, we are the same. You get me. And so I think a lot of his work is really unique in that aspect, and really encapsulates a lot of the mentality and the sort of the ethos of many virus writers of the time of using virus writing as a way to speak, to have a creative outlet, to connect with other people. So,
Is it kind of? Do you think he's thinking of the without inadvertently quoting Bowie, destruction? Use the beauty of the destruction that you're putting the victim under, like trying to create something, just an interesting processed way of destroying something, as opposed to what you had mentioned was like, just I can delete a file, that's not hard.
yeah,
But like, can I do it by like corrupting it or misdirecting the master boot record, and like how the file structure is and so forth?
yeah, and I think like even in Spanska's work, or even in a lot of other virus writers' work, the destruction of the system wasn't necessarily as important as like a successful propagation of a virus.
Mm-hmm.
So a virus being able to travel to many different machines or completely take over a host machine to the point of it perhaps being unusable or being really, really altered.
Mm-hmm.
I think that's more of where he's coming from, but it's hard for me to tell because, I don't know him personally. Sorry, what was the question?
Well, I think you're answering, but it also sounds like you're acknowledging the fact that in many ways you're an archaeologist,
Yeah,
and a historian.
yeah. I mean,
Which
a
is
lot
very
of this
interesting to think about the 80s as like a time period that we're coming back
right,
to
right.
mine.
But it's early internet history. It's relatively early computing history still. And it's an area of malware history specifically that doesn't get that much attention, or I think it doesn't really get the respect that it deserves, because the techniques that these authors were using and developing and creating were so foundational and laid the groundwork for so much malware. I mean, the entirety of malware as it is today, especially bootkits. I mean, the legacy of these bootkit techniques that these virus writers were using at the time was relevant up through, I guess, like Windows 7, like to a T. So it's just astounding.
What, all the malware went away in Windows 10? I doubt it. Or Windows 8. No one counts Windows 8.
So in Windows 8, it was like the switch to UEFI for the boot process.
Okay.
So the legacy BIOS like landscape where bootkits were just so prevalent, just really switched. But I mean, now there's a really rich, I don't know, ecosystem of UEFI targeting malware, that builds on a lot of those techniques.
And then comes along us firmware engineers and IoT, and we're making the exact same mistakes that were made by the Windows folks 20, 30 years ago. It's great.
Well, we are like we're always 15 years behind, so I guess that's kind of
You'd think we'd
expected.
learn.
No. We're doing it ourselves.
We can do it better. Yes, sure.
Yeah. Okay. So earlier, you said that you would other people had mentioned like, oh, there was no graphics, there like that there wasn't an intentionality in making these viruses or malware. I might have what you had said earlier that somebody had said, which was something to the effect of that, like malware and art were separate, and it wasn't it just people making graphics demos or something like that. Do you think that it's possible? I don't know if I probably have your words completely mangled, and I apologize.
No, you're good.
But I'm wondering, I'm kind of wondering if people are misremembering that period in like the late 80s and up through like almost 2000, when people would make graphics demos just trying to like outdo each other, using up as much CPU power as was available basically, but to just kind of like give something visually stunning and interesting, and they're confusing that with malware in that period. Do you think that that's possible?
Yeah, I mean, I think that's certainly part of it, and I think one of the roots of some of these misconceptions just comes from people who have only looked at, I guess we could consider modern malware or malware within the last 10 to 15 years compared to malware of that time. And it's like trying to compare MS-DOS as an operating system to current Windows and like how malware on modern Windows interacts with the operating system and manipulates it to how malware of the MS-DOS era was doing different malware techniques. It's not a fair comparison just because, I mean, MS-DOS didn't have security mechanisms in place. It was like, what are memory protections? You have to handle, like, you know, freeing your mallocs and everything. We're not doing any of it.
Well, first of all, what do you expect out? If I remember correctly, like even MS-DOS 622, I think was on 2 or 3 disks, and that was it.
That sounds right.
And compared to like whatever we have to do now to like freaking get Windows onto a computer is like utterly immeasurable by comparison.
Exactly. Yeah, and I mean, just like the layout of MS-DOS itself was so drastically different. I mean, a single task operating system where you're working in like with a 16-bit address, like you're trying to manipulate a 20-bit address space.
You have to far things.
Yeah, exactly.
Far. Okay. I don't know why my voice went up for that, but far.
It's great. It's emphatic.
Yeah.
So you mentioned some by Spanska. What are some of your other favorites and why?
Yeah. I think within sort of the realm of Spanska and similar writers, there's Spanska and then there's Dark Angel. So both Spanska and Dark Angel were really, really excellent in terms of the techniques that they used for polymorphism and writing polymorphic engines. And so polymorphism is a technique that's used in a lot of different things, but
but in this one,
it's a technique that's used essentially to generate altered copies of a virus upon each generation. So it'll create a new decryptor and then encryption routine, and so it introduces a ideally high degree of variability between each generated iteration of the virus. And so it helps reduce the amount of similarity between different copies of virus so that when an AV product or an antivirus product is looking for byte signatures that it can identify, maybe it only finds one and then it thinks, oh, okay, this virus isn't here anymore on the system. But in reality, there's like, 1,000 copies and they all have slightly different byte patterns. So that's,
so entropy,
I guess.
So it's using entropy.
Exactly.
But functional entropy, if that, I don't know, like it still works as a virus, right?
No, I'm just thinking about like it's so clever in that it's like it's like all the stuff that we've just gone through with the pandemic. It's like, oh, it's this version, it's alpha, it's this, like, and we have to keep like modifying like how we look, how our immune systems look for it, how researchers look for, how to block it to come up with the next immunization or antivirus.
Exactly.
Yeah, interesting. Like how much of those same concepts can like, hold over into computers is very interesting.
Yeah.
So now I'm kind of wondering, not that I'm putting you on the spot to answer this, if you know, great, but I am kind of wondering aloud. So how do antiviruses determine or decrypt or go like, oh, I'm looking for, byte sequences, like this type of entropy pattern, relative entropy pattern, because I'm not going to find the absolute because that's like old, that's not going to be helpful here. But how do I generalize what I'm looking for so I can eventually find something that a virus that we know exists that is several generations from when we originally found it? So I'm kind of wondering how antivirus figures that out on your machine in real time.
Yeah. From a modern perspective, I can't say that I'm very well versed in how modern AV works. I do know that Windows Defender does accurately detect that some of my 16-bit malware samples that are running in my Windows VM are possible threats and it won't let me run them. So good job, Windows Defender, really detecting tequila accurately. Like that's a crowning achievement. But in terms of how they work under the hood, I can't say I know all of those details. I know a little bit.
They don't want you to.
I know, right? That's a shame.
There's that conspiracy theory out there that the virus makers are the antivirus sellers.
It's not 100% wrong. I mean,
I know. You have to wonder.
Yeah, I mean, there's a long-standing history of sort of like wink and nod collaboration between virus writers and antivirus companies.
Mm-hmm.
So,
but we don't want to spread that theory much more. Like we're not pro conspiracy theory here. We want to be very grounded in reality and truth,
facts
at all points of time. And we also don't want me whacking my microphone out of excitement for Windows.
Jen loves Windows so much.
Like just flip the table, flip the mic. Sorry, man. I don't mean to hurt anyone's ears with that. I'm just like so sorry. I was like, sorry,
it's all right. This is all fun. So I'm gonna take a total detour, but something you said earlier, like much earlier, you mentioned reverse engineering art techniques.
Mm-hmm.
How does that work? Like, did you see a piece and you're like, how did they make it, or did you try to reverse engineer their thought? What
does that mean?
Yeah, I think it's like a very piece specific process or artist specific process. But I mean, my own art process is very process based. I don't want to like get too heavy into art terms because I'm going to have to define. Actually, I don't mind defining all of them, but might get rambly. But in terms of how I like to approach it, I guess like one example, there's a painting sort of master copy I did, which is a process that's pretty well established in like art schools and things, just in terms of developing technique. So you look at a piece that's created by a quote unquote master in the genre or the medium that you're working in, and you try and replicate it. And so this can be, you look at sketches that they did, you like understand by reading about them, or if they're alive, trying to talk to them, or reading whatever materials they've published or interviews with them, talking about their process and how they approach working on a specific piece. And then you try and apply those techniques to recreating it in your own style, or it can be either your own style or like as close to a one-to-one copy as you can get. But it can get really, really minute in terms of like looking at different like glazes that you're applying on if you're working on a painting, and trying to replicate the exact like way that light hits a glaze to mimic the, sometimes it's older, so to mimic that same way that the light interacts with the piece, I guess.
No, that's really cool. Now I'm thinking like, ooh, art forgery, like that's reverse engineering.
Well, yeah, exactly.
So
yeah, there's
I can tell you, having gone to Lisbon and taken many tours about the tiles, there are studios specifically that look at the historical ones and reproduce those as the older ones break, that are several hundred years. And yes, they're going back and trying to redo the glazes and the techniques to get,
That's sweet.
And of course, there's art forgeries like everywhere. So yes, the technique, the paint technique, the technique as well as the materials and reproducing the materials becomes very finicky.
Yeah. No, I remember when I was listening to a cheese podcast, there was somebody mentioned reverse engineering cheeses, and this is reminding me of that. It's like, okay, how can we make this like this?
And cool. I think it's so cool. What?
I just wanted to mention that because you mentioned it at the beginning, and it kind of got stuck in the back of my mind. But we kept going on the MS-DOS malware, and I was like, I'm not going to find a good time, so we can go back to MS-DOS.
Alvaro, was it like a virus that it got stuck in there?
Oh,
nice.
Oh my!
It infected my brain. We did warn you that there would be giggling.
Yeah,
this is.
I'm here for it.
Good.
Down to giggle.
Good.
All right, so now everyone's pumped about MS-DOS malware and they want to do it themselves. What are some good resources for people who want to try this out?
Yeah. So let's see. I have some resources. So I have all these GitHub repos, and I have a blog. So I've been documenting my research, and some of the larger groups of techniques. So I have a couple posts about TSRs, which are terminate and stay resident programs. So there's that. And then on these places, I have lists of other resources and other tutorials and guides. There's a pretty extensive list, I guess, but I can try and like think of all of them.
No, I mean, if you have them written down on your website and blog posts, that's perfect. Like, what better than one link that people can go and read all the things. So I feel like you did the work for us. I appreciate that.
Do what I can.
So, okay. So what you're saying is it's easier to get started online, and there's no like specific books that you have to mine and hope that somebody has on hand to learn any of the assembly or anything like that.
For learning the assembly, I mean, that would be kind of a separate thing. So I guess a lot of this project is like predicated on the fact that I had a background knowing a decent amount of assembly. Like obviously my assembly skills have drastically improved since I'm now like writing assembly programs pretty like several times a week for this project. Mm-hmm. But yeah, like getting that foundation of even knowing assembly in the first place is good. For like x86, because these are all...
Is it important, you think?
I mean, generally, or for this kind of work?
For this kind of work.
Yeah. Oh, yeah. For sure. It's like pretty essential. Because, I mean, any of the source files that you're reading through, they're all assembly, other than like the one basic one.
And or Pascal.
Or Pascal. Or Pascal.
And you don't really need to learn Pascal, so...
No one does. I actually have never looked at Pascal. It's probably fine. I looked at the one basic one and I was like, this syntax this is like Rust. I don't want to deal with this.
This is how I learned to program.
I'm sure Rust is fine, but yeah, it's...
Oh no, don't tell me that. I'm supposed to learn Rust for my new job.
I hear it's... a lot of people talk about it.
It's fine.
What a compliment. I hear a lot of people talking about it.
People talk about it.
Fact. That is true.
It's like... I'll put that on a shirt and wear it to work. In the meetings. Rust. I hear people talk about it.
It's not wrong.
You come with me to work.
You know the Go language has like a little mascot thing, right?
What?
There's the Go programming language, and then there's Rust. But somebody made little stickers of kind of mixing the two, like putting the logo of one with the name of it. I'll have to find them, but it's such a if you want to tell your coworkers.
Mm-hmm.
That sounds...
I like to make friends at my new jobs. Thank you.
Stickers are a way to make friends, I think.
Right. That's true. Yeah. But if I haven't met them physically in person, it's hard to give them stickers. How about I just go up to them and do this little thing? That's not gonna... Alvaro?
Nobody can see this, Jen. This is a podcast.
I know. I know. That's why it's so funny. Okay. For the listeners, I'm doing the little Korean K-pop heart thing, which you should not do to your coworkers unless they know exactly why. You've told them like. Well, it's funny because they made an emoji for. Well, no, I'm just saying that they made an emoji for it. That's all I'm going to say.
Oh, they did.
Yeah. Some people who make emoji.
If it makes it into Unicode, then it's
pretty cool. But I just thought it was so funny. I'm like, I just want to use it like all the time.
I just want to highlight.
I'm an old person.
Correct me if I'm not supposed to say this, but I think it's public now, right? You're going to be presenting at Recon in a couple of weeks?
Yeah, it is public. Yeah.
Yes.
Come to Recon. Come see my talk at Recon.
Yes, do it. Since everyone at Recon probably has never heard of us, but if you have and are listening to this, go check out Nika's talk.
And do this. Like go up to them and do a little K-pop.
Do a little.
Yeah.
Oh, if anyone does
you'll
that,
get a sticker.
I would be surprised, but that would be so cool.
I would be thrilled. I'd be so thrilled. Everyone
let's just send her some stickers, and she'll just like anytime someone goes up to her and does that, it's like they'll get a little sticker.
You'll know that they heard this.
Yeah.
That's so cool. All right. So we've mentioned reverse engineering, we've mentioned art, and in your projects, you're combining both.
Yeah.
How is that happening? Yeah. Why is that happening? All the things.
So
where is this happening?
When is it happening?
Oh my God.
Who is it happening? That doesn't make any sense.
That one's probably going to be the hardest because who am I? How do I answer that? Okay, so how it's happening is I've been writing essentially demo viruses or demo bootkits, partly as a way to learn, just to recreate a lot of the techniques and a lot of the samples that I've been working on. In part, it's also easier for me to rewrite some of them than try to alter the syntax in some of the assembly files to make sure that they actually assemble correctly. So I've been rewriting some of these bootkits and writing my own. And then I've also been combining it with graphical payloads and graphical routines that I've learned basically over the course of working on this project in terms of how to write 16-bit graphical routines. And inserting those into the bootkits. So combining what are essentially graphics routines to show my own art within 16-bit bootkits.
And what's your favorite, I'm trying to remember, what's your favorite video mode? I'm trying to like remember like when I was doing any of
13? This. Well, like hex 13, which is
right.
19 decimal, but hex 13 and interrupt 10, which is the video graphics interrupt. If you set it to 13, it's 320 by 200 256 VGA mode, so that gives you all the colors and
all of them.
all the colors. There's some really cool stuff that I've seen in terms of people who are doing demo scene work and like presenting at places like Layer 1 and just different demo spaces. But there's so many interesting things that you can do in order to get like more colors within that. So it's a cool space.
Would you say that you can lose all your files in so many colors? Sorry. Sorry. I think only Alvaro might get this, and he has a blank face right now. Remember, we had somebody, it was 16-bit, and they said you can lose in so many colors on QVC. I can't hear you anymore.
Oh, yeah.
Are you muted?
How long have I been muted? I don't know. Wow, I've been answering. Yes, that was the Jerry Ellsworth episode, wasn't it?
Yes, it was.
Sorry, I've been responding.
I just
and then
love
you just
losing,
keep talking.
losing.
You're like, what? I muted myself.
That's okay.
Because I've been coughing.
You haven't been doing all this podcasting for very long, so.
Yeah, episode 26, you can lose in so many colors.
Yes,
the only episode with a part 2.
But yes, you can lose all your files in so many colors. So do you have like a favorite like graphical element that you like putting in? Do you have like your own little logo that you like or sprite that you've been putting in? What have you been doing?
I've been doing a bunch of different things. So I've been creating little different sprites. And I've also been working on taking images that are scans of like drawings or prints that I've done. And then I have a Python program that's essentially like reducing them and changing like the bit depth and everything. It just basically turns it into like bunch of strings of hex characters that I can then put into the assembly program, and then it'll output them. But yeah, it's like essentially generating the sprites from my pre-created art. And then I also like doing just weird things where I'm writing patterns randomly to the BGA buffer and then seeing how like different palette changes affect it, and then how it's responding to things like keystrokes or timer ticks. It's kind of just a fun process of like playing around and having fun with it, and then seeing what the result is.
have you started? Okay, so you've done the graphics. Have you started playing with the sound engine at all? Which I don't remember which interrupt that's on.
No,
That could be really interesting for you. As somebody who, for my college project in assembly, wrote I don't know why I wanted to do it. This is not even remotely like a good thing. A musical screensaver.
Hell yeah.
I love that. Oh my God.
I don't know why I was like, I really want to do music.
Let me annoy everyone with the computer's idle.
So think about it. You take all the keystrokes from the buffer that's in there, and now that somehow that gets converted into like musical notes, and then you play those out.
And now you can never unlock your computer because the keyboard's being captured by the screensaver.
Oh my God, that's so good though. I love that. Okay.
Oh yeah, you're stuck. Just you must play music. You can do nothing else.
Yeah.
Oh, this.
I just love the idea of like you're just on stage. You know,
your
you're
computer's
like
now piano.
You're in your Daft Punk helmet, and like
Yes.
you downloaded your virus, and now we're ready to play the jam.
No, but that's such a wholesome virus, making everyone learn music. It's like, yeah, I like it.
Man,
it's very
you
wholesome.
Man, you used wholesome. This is how I know I'm old. That wholesome word.
Well, you can make it mean and have it do something like marine, which is like a different virus I like, where it's writing, where it's encrypting the drive while it's playing a fun little animation on the screen. So,
well, it's kind of like
just because it's malicious doesn't mean or just because it's pretty doesn't mean it's not doing something malicious.
Sure. So like, so like the virus is encrypting your whole thing, right? And you're fanatically like tapping on your keyboard or whatever, but that's just using and mouse and like just taking an input so it can like create an encryption key for your drive. So you're just adding all that entropy, just like when you're making your key on Git. Is it Putty that uses it? I don't remember. Putty keygen has like that kind of thing. Like just move your mouse around and it's like using.
Oh yeah. SSH. No.
Yeah.
Some
one of them does.
What was TrueCrypt used to do it?
Yeah.
It's like move your mouse around a bunch and we'll see the random number.
You can screw yourself over in so many ways.
Now I'm not muted.
Congrats.
Should we do tools? I want to do tools.
Yeah.
What are some of your favorite tools?
Nice.
I am a master of transitions.
Excellent.
So tools.
Tools.
Yeah, some.
So many tools. Okay, so Okay.
Yep, tools.
Okay.
All right, tools. So favorite tools for reversing. I love R2 just because I like its minimal interface and aesthetic, and I like its flexibility and extensibility. And I wrote a plugin, so I obviously like it.
You're invested. I
am invested. I'm in too deep at this point to really pick another disassembly framework. I do like Ryzen and Cutter though, so big internal conflict there, but like I feel like I can like them both.
We heard.
They're both great, so I use them both. And Cutter's nice. I like they have a decent amount of like 16-bit support that's built in. It's not like perfect, but it's pretty good. And what else do I use? I do like MASM32 occasionally, just because of that button, just because of the car button. But it's also nice having for anything that's written like specifically in MASM syntax. It's really helpful. And then like Box is great. I do so many things in QEMU, so that's a fun time. FreeDOS itself is nice. I don't know if I would call it a tool, but like just the FreeDOS is an operating system. That's great.
I wanted to go way back in time because some thoughts just came up. These are just completely incomprehensible thoughts that I'm just going to put here on the podcast. Were there any? Is it OS2 viruses? And Have you considered looking at those? If so.
Were there any OS2? I know that, okay, well, in terms of like early viruses that I know, there might
Mm-hmm.
have
Mm-hmm.
been. I know the earliest virus, the like earliest virus on record, was actually a worm, but it was called Creeper, and it targeted PDP-10s.
Mm-hmm.
And then the first antivirus solution was Reaper, which the whole point of Reaper was just to go in and disinfect machines that had been infected with Creeper. So it was like the nice little combo of Creeper and Reaper.
Mm-hmm.
And then the first, let's see, yeah, I know the first like pre-Mac malware was Elk Cloner.
Mm-hmm.
But I don't know.
Yeah. I don't know how many people actually bothered to use OS2. So that's why I was kind of wondering if anyone even bothered to like make a virus for it.
I'm sure.
Sure.
Based on the creativity and,
Boredom
of all of these writers, I am sure someone did. So
yeah. Okay. Back to tools. Now a transition. If you were trapped on a desert island, which tool would you bring with you?
Oh my god. Okay, what are the parameters of this?
Probably not MASM, I'm guessing.
Oh no, I would only bring MASM. I would only bring MASM just for the car button, and then I would die within like 2 days.
I feel like, I mean,
But you would
this
die
feels like a
happy.
very short...
I would be so thrilled.
It's just in my head, this is like not Sellers of Tab. What's the freaking thing where the old computer game where you're like where you're a settler and you're dying.
Oh, like
Oregon Trail?
Oregon Trail.
Yes,
yeah.
it's like an Oregon Trail but on a desert island. You die of MASM. You die of starving of MASM.
That's a way to go. I feel like that's the way I'd want to go.
Okay.
Actually, I don't know. What are the parameters for the island? Like, how long am I there? What's the point of me being there? How
there was a horror. Okay. Let me set this. Okay. Kind of like you were on a soccer team and you decided to take a private flight to your game, and you
Isn't
happened
this like
to
Yellow Jackets or something?
Shh, they don't know about this. It's not. You're just dating you're just dating this entire episode. And instead of like going over Canada, you just go over like the Bahamas, and you crash on a very isolated desert island. There's some palm trees. It's not very big. There's some food and some rodents. But your black box completely smushed. Maybe you can get it working, and you don't know. But you're stuck there for the indefinite future. What do you do? What would you wish that you had in the plane with you?
Probably all the books that I haven't gotten around to reading recently. I guess
you like a volleyball?
Yeah, I mean, I'm Tom Hanks now on this island. It's happening.
What do you name your ball?
Oh my god, Spanska. Box. No, Box is so good. I love that.
Your ball is named Box. Yes. I'm sorry, Box. Great.
All of the most technical talks here.
and finally, another question.
Yes.
She's like, good God, when is this going to end? Like many of our listeners, Alvaro and myself tend to stockpile old equipment from the 70s, 80s, and 90s.
Lies.
Possibly. Oh no, you totally stockpile. Maybe because we're worried that we can't get one later in a pinch, like maybe we end up on a desert island, who knows? Or we're just truly nostalgic. Whatever the case is. What piece of tech from that era, which is a very broad era, would you hold on to, and why? If you don't already.
If I don't already. Wow.
You got that at the gift swap, didn't you?
Yes. Sorry.
Good Lord.
I'm sorry I interrupted you silently, but I interrupted you.
You need to give her time to think. This is a good time while she's thinking. This is a good
Yes.
time to mention that we get a lot of crap at the Mountain View Hardware Reverse Engineering Meetup, which has usually in January we have a gift swap of who knows where all this crap comes from. Probably from the electronic market that is now happening again at De Anza College. Anyway, now that you've had some time to mull it over, because I can answer what I think I should have.
I mean, I would say keep all of it, but I guess that's not practically feasible. I think,
Some try.
yeah.
Yeah, we know them.
We know them.
Okay, I would be interested, just like based on where I'm at in this project, to get my hands on any machine that was created at that time where I could like run DOS viruses on it and not have to use an emulator. But I've also been really interested in looking at a lot of like the Soviet like counterpart machines,
Mm-hmm.
just because a lot of really good virus writing happened there
Mm-hmm.
and continues to happen in
Mhm.
like Eastern Europe. So, but I think the very, very interesting history of creating these replica machines within the Soviet Union at this time is so fascinating.
Mhm.
So I'd want like an old Soviet computer next to the original that it was copying, and then like
Mhm.
doing a doing a diff of the two.
Yeah,
Oh,
yeah,
that'd
yeah.
be fun.
That would be just even
That's like
yeah.
a Ken Sheriff worthy blog
Yeah.
post right
Yeah,
there.
yeah, absolutely. Just even because I grew up in Europe, and so my earlier experiences with computers were with with the European computers compared to the American ones. There is kind of a cultural difference there that I felt. Yeah, so it's interesting. Yeah, I don't know anything about the Eastern Bloc ones, but I've heard the stories there. For me personally, I just want a 5 and a 3.5 disk drives. Not disk drives, sorry. Floppy disk drives. I feel like that.
All the floppies.
Yes. If they're still, if they're still working.
Yeah.
It just feels
seriously.
like that's what's hard to come by.
Yeah.
What about you,
absolutely.
Alvaro? I know you held up something. I don't know what you're going to do with
Oh,
that.
I don't know what it is. So
It just takes up space.
it has 110 buttons or 120
I
buttons.
think it's how you switch calls.
Yeah, it's an old phone switch. Oh, here. AT&T Model 26A, a direct extension selector console. But yeah, someone in the reverse engineering meetup reverse engineered this. And so you can plug into the back and then drive all of these different lights and read all these different buttons. So maybe I'll make a music machine out of it or something. I don't know. It's been in my closet since January, but but I have it.
Do we have any more questions? Is it time to wrap it up?
I mean, we could go forever, but
Apparently we could giggle forever. We could make up more random questions.
Always.
So, what you got?
So Nika.
Final words.
Nika. If you want to be found, how can people find you?
You can find me on Twitter. I'm Nika Roxanne on Twitter. And then I'm Ice Queen with all the E's or threes on Mastodon and Discord and all the other things. Yeah.
And is there anything that you'd like to plug? I guess your recon talk.
Yeah, my recon talk, Portrait of the Artist as a Young VXer. This painting is an MBR boot kit. Come see me at Recon. There's also a lot of other cool talks at Recon happening this year. So just come to Recon. Let's see, what else? Oh, I'm going to shout out my friend Ben, who introduced me to your podcast. So hi, Ben. His handle is Suidroot. He has a really cool blog as well that I'll send you the link for, so you can put it in the show notes. But yeah,
hell yeah,
he's great. He does malware reverse engineering and like hardware embedded stuff too. So
cool. Alvaro, where can you be found?
I'm on the internet.
Idea.
My website's alvarop.com. I'm on Twitter, Alvaro Prieto. I'm on Mastodon, Alvaro at Mastodon Social. I'm on Blue Sky. I don't remember what I'm called there, but I'm on there too. Yeah, I don't know. I just keep adding these things.
Congratulations. Congratulations. I can also be found on the internet. I have at jencastillo.com, at rebelbot.com, on Twitter at rebelbotgen, also on Mastodon, same thing. Also on Blue Sky, I think the same thing. I don't know. It shouldn't be that hard to find any of us at this point, especially with all these.
I mean, if you're listening, you probably know who we are.
And you probably have heard our voices and known who we are before you looked at us. Probably. Still creepy. Anyway, so do you have comments or names for the show, or you want to just talk to us? You can find us on Twitter at, because we're still on Twitter, at unnamed_show, or you can hit us up on this comment form that we only check every few years, and it's kind of hilarious if you guys write there, because we look at it and we're like, oh, this is pointless now. If you still can't find us, you can go to unnamedre.com. That's unnamedre.com. We have some more Patreon supporters that are new. We got Scott, Bob, Rasmus, a past guest Cyber City Circuits, because they're hilarious to me and they signed up. Reed Possum, Thomas, Daryl, Simon, Mark, Mati. That's cool. Okay, another Scott, another John.
How long since we last did this?
It's been a while, so I'm just going to a certain point. And
Thank you so much.
And it goes on and on and on. You want us to shout out your name? Why not? Join us on the Patreon.
Or introduce a guest.
Or introduce us on a guest.
They'll shout you out.
Apparently.
Because it's awesome.
If you have time, it would be wonderful if you shared your opinion of us, good or bad, hopefully good, by reviewing us on your podcast app, whether that's iTunes, Stitcher, Spotify, I don't know what else, Google something, Amazon something. I don't know. There's a bunch of these. Put some nice things in there and we'll say thank you. I think that's it. Is there anything else that I didn't do on this list?
I think we're good.
Oh my God.
Thank you so much for joining us, Nika. This was so much fun.
Thank you, Nika.
Thank you so much for having me. It's been so fun.
Okay. Till next time.